Hey everybody, welcome to the video on similarities. Today we are going to focus on two goals. We're going to determine if figures are similar using transformations, and we're going to use scale factors to determine a missing side of a similar figure. As always, our essential question is, how can we determine congruence and similarity? So here we go. Alright, again, as with any time we're taking notes, we want to make sure that we understand our vocabulary. So here's some vocab. Some of it is review and some of it is new. So make sure you're writing down the new vocabulary words for sure and adding notes on the review vocab just to make sure you know what they are. So what does it mean if something's similar? If something's similar, that means one image can be obtained from another by a series of transformations or dilations. That essentially means I can take one figure and map it or completely put it over another by transforming it and dilating, stretching, and shrinking. A similar figure or similar polygons are polygons that have the exact same shape, and their corresponding angles are congruent, but the measure of their sides are different. One might be longer, one might be shorter, but they are going to be proportional to one another. And we're going to talk about what that means to be proportional in a little bit. Again, we're going to be using the words transformation, which is an operation that maps a figure from a pre-image onto a new figure, the image. Dilation is a transformation that enlarges or reduces, stretches or shrinks a figure by a scale factor. And that scale factor is really what we're multiplying by to get from one figure or pre-image to the next. Or the ratio of the lengths of two sides of our similar polygons. Alright, before we go farther into this unit, I'm going to talk about finding the scale factor, again, in between two figures. So again, the scale factor is how I'm increasing or decreasing that size of my shape. So in order to do that, I'm going to create a ratio, like we talked about in our vocabulary. So I'm going to look at these green rectangles here, and I'm going to identify the corresponding sides, or the sides that are the same or similar in the objects. So in this case, this side of my triangle or rectangle and this side of my rectangle are corresponding sides, and this side corresponds with this side. So now that I know which sides correspond in my figures, I can start by building my ratio to find my scale factor. I'm always going to take my larger of my numbers. So in this case, if I'm looking at my red sides, my red corresponding sides, I'm going to take the 4 and I'm going to divide by 2 to create my ratio there. And I'm going to do the same thing for the blue sides. I'm going to take 6 and I'm going to put it over 3. Now both of these will reduce down to a scale factor of 2. So in this case, the scale factor between these two rectangles is 2. I can do the same thing for these triangles over here. Again, I'm going to start by identifying corresponding sides. So these figures look the same. This side of my triangle corresponds with this side, and then this side of my triangle will correspond with this side. So again, now that I know what my corresponding sides are, I can build my ratio, starting with my bigger number figure first. So if I'm looking at my green sides, I've got 9 over 3. And the red sides, I have 18 over 6. And again, if I reduce those fractions down, I'll find a scale factor of 3. I would recommend having some examples like this down in your notes so later on you have something to refer to. Okay, so let's put those things that we've talked about in practice. Let's determine if these two triangles are similar by using transformations. And then we're going to use our corresponding sides to build a scale factor. So number one, the first thing we're going to look for is, are our figures, do they have the same orientation, or are they turned the same way? And in this case, they are. They have the same orientation. Again, orientation means they're turned the same way. Then I'm going to look, can I slide my smaller triangle onto my larger triangle with a transformation? And I can. If I take my triangle EDF right here, this triangle right here, and I want to map it onto my larger triangle here, I'm going to slide this triangle down to and over 5. That will line point D up with point G. So I'm going to take my triangle, and I've got point D that I'm adding here. E is 4 points up, and F is 3 points up. So now that I have my triangle translated, which I need, that's my second step, I translated it and I went down to and over 5. And this was a translation. My very last step then is to find, did I dilate this smaller triangle? Did I stretch it and keep a ratio or stretch it by a similar scale factor? So again, I'm looking at corresponding sides. So in this case, the sides that are overlaid are my corresponding sides. So HG here is the same side as ED. So HG is 1, 2, 3, 4, 5, 6, 7, 8 units long. ED is 4 units long. Then I'm going to look at these two sides as well. I have GI, which is 6 units long, and I have DF, which is 3 units long. So in this case, again, I'm going to look to reduce these fractions down and find a common scale factor, and the scale factor is going to be 2. So if I were asked to determine if these two triangles are similar by using transformations, I would say yes, because if I translate the triangle down to translate the triangle EDF down to and over 5, and then dilate it by a scale factor of 2, I will have my new triangle HGI. Okay, we're going to do something similar here. We're going to determine if these two rectangles are similar to one another. So what I'm going to do first, again, is we're going to look and do they have a similar orientation, or are they turned the same way? And they're not. So I first need to turn or rotate one of my rectangles. In this case, I'm going to take my smaller rectangle, VWTU, right down here, and I'm going to rotate it up 90 degrees about point W. So W is not going to change. And I'm going to rotate this up 90 degrees to be in line with my other rectangle, WXYZ. So 90 degrees, here's where my new T would be. My U would be right here. And V is going to be right here. Here's my new rotated rectangle. So now that I have the orientation the same, I can look to translate or move my shape so that it lines up. In this case, I don't have to move it very far. I actually only have to translate my rectangle 3 units right. All I'm doing is sliding this rectangle 3 units to the right. 1, 2, 3. So now, here is my rectangle. I've got point W here of this rectangle. V matches up with W here. T and U. Now my very last step is I have to determine if I have similar sides based on determining a scale factor. So I'm going to look at my corresponding sides. So now here VW corresponds with WX. So again, I'm going to take my bigger number. So WX is 4. VW is 3. And I'm going to do the same thing for another set of sides. So if I'm going to use the other side that's touching, I've got ZW, which is 6. Oop, nope, 7. Got ZW, that is 7. And I have UV, that is 5. So now I'm going to reduce these down. So I've got 1 1/3 here. And this is 1 2/5. These two ratios do not equal one another. That indicates if, even though I could turn my figure the same, I could translate it 3 units to the right and map it onto the other rectangle. Even though I could do those things, it is not, these two figures are not similar, because that last step of being able to dilate it or increase it by that same scale factor, all the sides by the same scale factor, does not hold true. These scale factors, these ratios are not the same. So we're going to use just scale factor in a word problem to indicate if something is similar or not. So here's a little peek into my life. My husband goes to Walmart and enlarges this picture of our dog Chip by a scale factor of 2. Then I decide to enlarge it by a scale factor of 1.5 to fit a picture frame in our living room. If the original photo is 2 inches by 3 inches, what are the dimensions of the new print? And are the enlarged photos similar to the original? Okay, so what I'm doing to start here is I've got my picture of my lovely little Poochie chip here, and it's 2 inches by 3 inches. Those are my dimensions. And my husband, when he goes to Walmart, he is enlarging it by a scale factor of 2. This is what we talked about last chapter. When I'm given my scale factor to increase my object, it just means multiply. So I'm going to multiply both my dimensions by this scale factor of 2. So the picture goes from 2 inches by 3 inches to 4 inches by 6 inches. But that's not good enough. I really need it to be bigger than that. I need it to fit a photo frame in my living room. So I need to increase it again by a scale factor of 1.5. So I'm going to again increase both my dimensions by 1.5. And my 4 inches times 1.5 becomes 6. And 6 times 1.5 becomes 9. So my photo of Chip has gone from 2 inches by 3 inches to now 6 inches by 9 inches. So these are my final dimensions. Is the enlarged photo similar to the original? The answer is yes, it is similar. All 3 of the photos are similar because each enlargement that I made was made consistently by the same scale factor. So from going from 2 to 3 inches, I multiplied both dimensions by 2. Then when I enlarged it again, I multiplied both dimensions by the same scale factor. Since those scale factors remain the same, they are similar. Another way we can talk about similarity is knowing about similar polygons and their properties. So similar polygons are polygons that have the same shape. They have corresponding angles that are congruent, and the measures of those corresponding sides are proportional. Again, when we're talking proportional, that means they have the same ratio, like what we were just doing for our scale factors. And congruent means that they have the same measure. So let's put that into practice a little bit. Let's determine whether the rectangles in this picture are similar based on our similar polygon properties. Well, number 1, a similar polygon has the same shape. Yep. Both rectangles. So we know that criteria is met. Our second criteria is, are the corresponding angles congruent? Meaning, are they the same? Well, if I look here, all of my angles are 90 degrees. So yes, my angles are congruent. And last but not least, I need to look at those ratios in between the corresponding sides. So here, I've got side JK and NP. So again, I'm going to start with my larger on top and build my ratio. Now I'm going to do the same thing with these sides. I'm going to take 10 and put it over 7. So I'm going to reduce these down. This one becomes 2, And this one becomes 1 3/7. As you can see, these scale factors do not match up. They are not the same. That means since 2, the scale factor 2, does not equal 1 3/7, these two shapes are not similar. Now I can use my properties of similar polygons to also find missing measurements. In order to do that, I'm going to use my corresponding sides and build those ratios again. So there's 2 ways you can do this, and I'm going to show you both ways. So if I have these 2 figures up here, and I'm looking to find the measurement of this side, I'm looking to find X right here, my little star. In order to do that, in order to find that side, I can choose to find the scale factor of the similar polygons, or I can set up the proportions. Either way will work. And again, this is only if they're telling you that these that 2 polygons are similar. And in this case, both of these polygons are similar polygons. So, again, in order to find the scale factor, I'm going to take corresponding sides and I'm going to set up a proportion. So, I'm going to take these corresponding sides DC and ZY. So again, if I'm looking at starting with my big number on top, my scale factor is going to be 1.5. So that means I can multiply anything in this first shape, any dimension in this first shape, by 1.5 to get a side in my second shape. So if I'm looking to find the measurement of side M here, I can do that by using the corresponding side in my A, B, C, D. So here's my corresponding side to this M measurement that I'm looking at, 12. So what I can do is I can take that side measurement, 12, and I'm going to multiply it by my scale factor of 1.5. That's going to give me a measurement of 18. I just figured out this measurement M. M equals 18. Another way to do that is with proportions. So I know, again, that side ZY is 15 and DC is 10. And I'm looking right away to set it up that I don't know this side of the side that M is on of my larger polygon, but I know that it corresponds with 12. So here are my proportions. Now you might remember this from earlier math classes. When I have proportions like this and I need to figure out what this number is, I can use that fish method or cross multiply and divide. So what that looks like is I take these 2 numbers and I'm going to multiply them. So So I'm going to take 15 times 12. And then I'm going to divide by 10, and it's going to get me my answer. So I'm going to start by going 12 times 15. Which is 100. 180. And then I'm going to divide by 10, and it's going to give me m equals 18. So that is how you can use your properties of polygons, of similar polygons, to figure out sides measurements. All right, last but not least, why was the little strawberry crying? Just the joke of the day. Remember, you can answer the joke of the day on the back of your sheet, and at the end of the unit, you can turn it in with all 5 answers for a Laffy Taffy.